So, good evening, Unadal, for this today's session. Today is the fourth day of the session, and today's session is going to be handled by Dr. R. Lawrence, sir, Managing Director, Macwell Software Solutions Private Limited, Sivakasi. And to welcome him, I request Ms. Uttara Devi, Assistant Professor, Department of Computer Application, to deliver the welcome address. Welcome, ma'am.
Ma'am, voice is audible, ma'am?
Yes, ma'am.
A very good A very good evening to everyone. It's my great pleasure to welcome you all to the ACT ATAL sponsored 6-day online faculty development program on data drive model, empowering academic for data science era, organizing by the Department of Computer Application, Nada Saraswati College of Arts and Science, Teni. I extend the warm welcome to our resource person, Dr. R. Lawrence, sir, Managing Director, Macwell Software Solutions, Sivagasi, for his informative session on deep learning with TensorFlow and neural networks. He is the academic and industrial professional with over 25 years of experience in higher education and software development. He had worked as the director of MCA and IQC executing member at Ayyanada Janakyamal College, Sivagasi. He has hired several research scholars and received award for his contributing to teaching and research. He is now the CEO of Macwell Software Solution, focusing on business automation, loan management system, and web development, and etc. With rich experience in both academic and industries. Once again, I welcome you, sir. This section is yours.
Thank you very much, Manavutran. So, am I audible?
Yes, sir.
Yeah, thank you very much. Okay, first of all, I would like to thank the principal management, especially the head of the department, Dr. Uma Madam, and the other team for organizing wonderful ATAL presentation. And above all of you know that from the introduction, you may know that I came from academic as well as industry, right? The same way I want to know about you. So for that, I share one URL. So it is just a poll only. Okay. Just you click and you give introduce about yourself, right? Just 2 minutes only, not more than that. I share the URL in the chat box. Now I hope my screen is also visible to you. And 1 minute, I will present. So now I hope I can visible the poll on your screen, whether it will be mobile or laptop. Okay. So until this others can join, you can click the survey. Yeah, only one has replied. Okay. Yes. Very few are responding. So totally this session will be interactive. Okay. So you have to actively participate. So we are going to learn a new thing today. Okay. Oh my God. I think there are more participants out there. Okay. So what do you expect to learn from today's five of them gave both theory and practical? Yes, majority give the answer, both theory and practical. Okay. So that's also my objective. Okay. So I'm going to give both theory and practical to you. Okay. So let me start the session. So as introduced by Madam, so I am the Managing Director of Macro Software Solutions Private Limited, Sivagasi, and we are developing website development, mobile app development, and we are providing AI solution to others. And especially, I came from academic background. We are mainly give training in AI, machine learning, and full stack development, especially men stack we are providing. So this is my short introduction. So before we are going to see about deep learning, okay, so we must know the history, isn't it? So let me show the history, right? So can you guess when the deep learning has started or machine learning has started? Any idea? Just to give in chat box. So most of the my presentation will be interactive mode only, right? So give any guesses, whether it is right or wrong. Your participation is very important to me. Okay, just a guess. When has the history of deep learning or machine learning or AI has started?
1959, sir.
Yeah, very nice.
I think MP neuron. First one is the MP, like McCulloch's neuron or something like that.
Superb, sir. Very good. Very nice answer. So exactly I want to tell the right. So as sir told correctly, it is started in the year 1943. Just imagine there was no computer on that year, right? So they wrote a paper. Baron McCulloch and Walter Pitts wrote a paper about how our neurons works. Okay, but it's purely theory basis only. Right? They simulate the model, how our neuron is work. Another question, can you guess how many neurons in our brain? How many neurons we are having?
10 to the power 14, sir.
Sir, who are you? You give me correct. Exactly. Okay. So more than 8 crores neurons we are having, right? So they are simulating a single neuron. They are not implementing. Okay. So just they proposed the theory concept only in 1940. This is the foundation for machine learning, deep learning, or AI. Before that, it has started, right? So I could not able to cover the entire history because it started from 1943. Today we are in 2025, right? I could not able to cover all things, but what are the important things that is I'm going to focus. Okay, so this is the foundation. So next, you may heard about this fellow Alan Turing. Okay, yeah, just someone has told Turing test. So in 1950, Alan Turing created the Turing test. Can you give what it deals with? Can you give any idea? What is Turing test? I think you may heard about this
Finite
fellow.
automata, sir.
Yeah, very good. Very theory of computation. You may study
Yes,
his
yes,
concept, right?
Yes, a
Yeah.
Turing machine. Yes,
Yeah,
yes.
Turing machine, right? Okay, so actually, what is the core idea is, I will tell the core idea late, but I tell the history first, right? So Alan Turing, because of him only, the Second World War has been stopped. If you get the time, there is a movie called Imitation Game in Netflix. You may go through it. So it completely deals with his biography. Okay, so he founded a machine called Bombay, and which encrypted all the uh, decoded words from German peoples. So he decoded the word where the bomb should be today will posted on something like that, right? So and he goes, he encrypted everything by using the machine bombing. Okay, so and he created a test called a Turing test, which tell that is suppose a human just like me. So I am interacting with a human, another human, and another computer. Okay, so I am interacting with a computer as well as another human. Suppose I could not be able to find which is human and which is computer, then the computer is passing Turing test. I hope you got the idea, right? So there is a intermediator. He communicated with a computer as well as a human. Suppose if we could not be able to find which one is human, which one is computer, then the computer has passed Turing test. So this is his idea. Okay. So and note it down. Till now, there is none of the machine passed Turing test. Consequently, it may be passed here and there, right? Consequently, it could not be able to beat human. So such a power we are having. So this is the second history. And you may know that Arthur Samuel, right? So he wrote the first computer learning program and he coined the term machine learning. So in the year 1952, and he built a game called checkers, right? You know, the Chinese checker, you know that. The machine automatically play with itself. Okay, so this is the first machine learning program which was created in the year 1952 with Arthur Samuel. And 1957, Frank Rosenblatt, he designed the first neural network for computers, so which has been proposed by Warren McCulloch, right? So he designed the first neural network for the computer in 1957. And 1967, the nearest neighbors algorithm, I think yesterday was, madam has been taught to you also how KNN is working. So the first, that algorithm used to find the pattern recognition. It was proposed in 1967 and 1997. So there is a long gap, 30 years almost gap. Okay, you know this fellow. He is the world chess champion. A supercomputer first time beat a man in the history. Not a ordinary man. He is the world chess champion, Gary Kasparov. Okay, so the machine has been developed by IBM. So 1967 to 1997, there is a winter season of AI, because the company has not come forward to invest the money in the AI because there is no proper result. So that's why that season is called winter season. The IBM first developed the Deep Blue machine. So first Gary Kasparov see the machine, he fighted with the people, why you are asking me to compete with the wired box. But unfortunately or fortunately, the machine has beat Gary Kasparov. After that, the second time he beat once again. That's the rest of the history. But he's the world history. Okay. So here our second AI era has been started because IBM has invested a huge amount of money for this, and all companies come forward, right, to invest the amount to AI. So Google, and you know that the competition is going on. Okay, so from that onwards, AI has been begun and started enormously. And he is Jeffrey Kenton. He created the first deep learning in the year 2006. You may know about this person. Anyone? Recently, in 2024, recently you may know about this person. Any idea? So he got the Nobel Prize for his work. Actually, he is a physics man, but he is working in machine learning and got there is a big debate was going on that times. Okay, He got the Nobel Prize for his research work, and he is the father of deep learning. Okay, deep learning, Jeffrey Hinton. So this is the history of deep learning, and now it has been evolved a daily. Okay, so now transformer has been developed, and it has been implemented in GBT and so on, right? So you know the history, agent decay, okay, lot of things has happened. Okay, this is the history of deep learning. Any doubt up to this? Are you clear? So type Y in chat box. I can proceed further. Yes. Okay, thank you. Okay. So next, one more question. So what is the relationship between A and ML, DL and DS? They are telling us several things, you know. Okay. So what is the relation? Whether they are same or different? Any idea?
They are like subsets of AI. So AI encompasses a lot of things, including expert system and all.
Yeah,
So
exactly.
ML and DL are like subsets of AI.
Yes, exactly. Super. So artificial intelligence, it's as Sir told, it is a superset or it is a broad term. Okay, so it is ability to imitate human intelligence. Okay, this is the overall umbrella. So under the subset of machine learning has been developed, right? So machine learning deals with a statistical and a mathematical model to deals with a large amount of data to find insight from the large amount of data. That's the purpose of machine learning. And what about deep learning? It is used to mimic our human brain. So consider where it's a mimic our human brain. So that's the core concept of deep learning. So that's the thing we are focusing today. Okay. And it is again the subset of machine learning. Gen AI is the subset of deep learning and so on. Okay, data science, it touches all the fields. Okay, so where is deep learning is used? So deep learning is used in many industries, from healthcare, transportation, e-commerce, especially entertainment. We will see details. NLP, natural language processing, image and video recognition, education, agriculture, and so on. So deep learning is everywhere, from your phone to space exploration, transforming how we live, work, and interact with the world. Okay, let us see some examples. I'm going to not deal with a lot of the examples, some example. Okay, so all of you know about this concept of Olo. Okay, Olo, yeah, Uber and something like that, right? So this is wonderful startup idea, isn't it? So before Ola, what happened? Suppose I boarded into Chennai, so I request for the taxi. Okay, so I bargaining with the taxi drivers. He after seeing my face, he immediately told, so there will be 500 or 600 something, right? I again continuously fight with him. Finally, we conclude come with that 300 something like that, right? So when Ola comes, there is no bargaining is there, right? I just downloaded the app and I have to tell my destination. It immediately tell the price. Okay, so behind this Ola, there is a huge amount of deep learning algorithm has been worked, because the data is generated every second through Ola's platform. You know that, so it has more than 9 lakh cars in this network. Okay, so they have the real-time picture of traffic conditions in entire our India, especially the high-level cities, where the peak hour is going and where the people, when the people will board it highly, and so on. Okay, and they are implementing most successful AI-powered real-time monitoring features called Guardian, almost in 17 cities of India. What will do? So the Guardian, so the app continuously collected the real-time data from the rides to spontaneously detect irregular activities by the driver. What is the irregular activity by the driver? Suppose if I am going to Sivagasi to Madurai, there will be a route. Okay. Suppose the taxi took some other route, then there is a problem. Okay. Or the taxi prolonged stay stopping in summer, then there will be some problem. Or the irregular behavior of driver, so like smoking or drinking. So all these information are continuously automatically collected. and given to the OLA's 24/7 safety team, right? So they take immediately the action. Both the driver as well as the passenger will be safe because of this Guardian now. So the concept behind this our deep plan. Okay, and you may heard about this one. So Amazon and Flipkart's a great freedom festival. So they are using heavily deep learning algorithm, especially in the name of recommendation system they are using. Okay, you know that there are more than lakhs products are available in Amazon as well as Flipkart. Okay, so how it recommended the particular product to you? Okay, they are using some algorithm. Okay, there's algorithm, collaborative filtering, content filtering, and knowledge-based filtering. A lot of filtering algorithms are there. Based on that, it will recommend to you. Otherwise, I could not able to find what is my requirement. So it's the biggest problem, isn't it? Okay, this is the concept behind is our deep learning or machine learning algorithm. And Zomato as Zugi, right? So when it comes introduce it in our city, so most of them are criticize who will use this Zomato or Swiggy. Nowadays, every week or every day, most of the almost all people are using this Zomato or Swiggy, and they are using our machine learning algorithm or deep learning algorithm. Say, for example, suppose they took a data. For example, let us consider in our area there is Vijay Mess is famous for non-veg. Okay, suppose regularly they sold almost 200 biryanis, and one day it will reduce. They immediately identify by analyze the data. They identify the sale is coming down, and they discuss with they deal with the hotel and give the 10% off. Okay, and this is also a wonderful startup idea. All right. So before Zomato or Swiggy, what has happened? So I like what is called idiyappam and article pie. This is a non-veg kind of taste, right? Suppose if I enter into a veg hotel, right, like Balaji Bhavan, something like that, right? So I cannot order non-veg from the veg hotel. Or suppose I enter into the non-veg hotel, I could not able to order the veg dish what I prefer. But now it is possible. From home, I can order from veg hotel and non-veg from the non-veg hotel. Right. So it's a wonderful startup idea. But the concept behind they are using our deep learning algorithm. And you may heard about this fellow, Prasant Kishore. All right. Any idea? Yes or no? Type yes or no if you heard about this fellow. Y or N, something like that.
Yes, sir.
Yes. Yeah. Okay. Actually, he running a company called IPAC. So almost 200 data science people are working in his company, right? And what is their job is, and you know that, so last time they tie up with our DMK government in our Tamil Nadu election. Okay, so they played vital role for DMK's 10-year vision document. Suppose if Stalin has come to Sivagasi, before that the team has arrived, and what are the problems they are facing, people facing, and how many people are there, how many girls or ladies are there, gents are there. Every data has been analyzed. Okay, based on that only they prepared, and Stalin has proposed. So Mr. Stalin has tell about how to solve the problem when he ruled. Right. So not only in Tamil Nadu, almost all cities, all states of India. Okay, they they are the behind the concept. So they are using data analysis. Even they collect a single data. Even they are collecting EB bill. EB bill. All right. Suppose my EB bill comes under 2,000, other people comes under 200 something. Some people pay 10,000 something like that. So from that they classify the people who are the higher class, who are the middle class, who are the lower class. Okay, everything they analyze by using our machine learning or deep learning algorithm. And Netflix, almost all of you heard about that. So everything is personalized, even a single row, each row or each column, right? So in our family, we have suppressed Netflix, right? Subscribe Netflix. For me, it shows something. So I am interested in action movies, right? My kids and my wives are liking some other movies like K-drama, something like that. So if I am logging that, so it recommended to me the action movies. So there also they are using the recommendation system. Not only that, so you know that a Tesla car. Okay, so they are also using our deep learning or machine learning algorithm. So it automatically detects the person in front of them, and based on that, when it should brake or something like that, right? So all things reinforcement learning you may heard about in machine learning, right? So they implemented our deep learning algorithm. Okay, there are a lot of applications we can discuss. Okay, so that's what the list is going on. Okay, suppose I want to become a machine learning expert, how to become? So you have to familiar with all kinds of things, supervised learning and unsupervised learning, reinforcement learning, and you must be familiar with any one of the language, either Python or R or Java, but we recommended Python only. Right, and mathematicals, you must be strong in mathematical concepts, statistics, linear algebra, differential calculus, and you must familiar with one IDE, either GPT, Jupyter, or VS Code, or something like that. And you must know the visualization tool, Tableau, Power BI, and so on. All right. Just imagine if you take unsupervised learning or supervised learning, there are a lot of algorithms out there. If you are going to start studying, I think it will take around 2 years if you want to become a machine learning expert or deep learning expert, isn't it? But always I recommend do the reverse engineering, take a project in deep learning or machine learning and do the reverse engineering, right? So that's my idea. I have done like this. When I choose machine learning, I don't know about Python, or I didn't know about machine learning something, anything. I take a project and I implement. Now I come to uh, I came to know a lot of things in machine learning and deep learning. So this is my recommendation. Okay. Right. So why deep learning is so popular? So why already is machine learning is there, isn't it? Why do you go for deep learning? Because of the big data. Okay, so in the year 2011, I think Facebook has been introduced. So from that, social media has been emerged. So they generate a huge amount of data. So they need a wonderful, they need a algorithm to handle the data, because the data is the new oil, you know that. All right. So on that picture, on that time, deep learning helped the people. Okay, that's why deep learning is so popular. Okay, right. Once again, I take the same example. So in the year 2006, you know that, so the Netflix subscription is only in US, they are having 6 million members. Now Netflix is everywhere, almost 100 million members, around 190 countries. So because of this deep learning, and Amazon got to 34% profit in every year because of this recommendation system. Okay, that's why the industries requires a lot of people in, especially machine learning and deep learning scientists. Okay. So what is the drawback of machine learning? You know that already machine learning is available, right? So why do you go for deep learning? What is the drawback of machine learning? Say, for example, the picture clearly represent what is the drawback of machine learning, right? So if the iteration going on or the data is increased, right? So see the accuracy, this the curve. The accuracy of the model at some time is stagnated. It could not able to process. So after this point, more data is diminishing, right? So the curve is, the performance is retained the same level. If the data is increasing, it could not able to handle machine learning. So machine learning only for some amount of data. If the application is too complex, then machine learning could not be able to perform. Okay, so that's the biggest problem in machine learning. Okay, so deep learning, see the deep learning. So at the data is very low, both are performed same. Okay, whereas the data is increased like this, the performance, see the performance, the traditional machine learning is stagnated, whereas the deep learning performs very well. So for the deep learning, we need large amount of data. Then only it will works very well. Okay, so this is the difference between deep learning and why what the drawback has been rectified in deep learning. Okay, and usually a deep learning algorithm takes a long time to train due to large amount of parameters. Okay, whereas the traditional machine learning algorithm take few seconds to train, few seconds or few hours to train. If the problem is complex, it will take some more time. So the scenario is completely reverse in testing space. You know the difference between training and testing, right? So at a test time, deep learning algorithm takes much less time to run. Okay, so during training time, it will take more time. During test time, it will take very less time. Okay, this is another difference. And you may know that so deep learning is inspired from human brain. You know that our human brain contains a lot of neurons, right? So similarly, we have multiple layers and connections. In the same way, the deep learning has been implemented. We will explore this concept in upcoming classes discussed. Okay, so networks of multiple layers and connections. Okay. Say for example, suppose if you see this is the biological neural network, how it works. Okay, so when you see the cat picture, the electric signal has been passed through our eye and our brain. Some layers only work. Some neurons get activated, not all neurons. So for if you are seeing something, right, some neurons get activated. If you're listening something, some neurons get activated. All right. So initially it will identify the shape of the picture, right? So curve that has been identified by the first layer. The next deepest features has been identified next level layer, and so on. Finally, it is has combined and it will identify it is a cat. So in this way, the same way our artificial neuron has been implemented. Say for example, if you give a cat and a dog picture, so this neural network, this layer, right? The first layer identify only the what is called a high level feature. Sorry, low level feature like curve, squares, pattern, something like that. Right? Each layer identify its own some high level features. Finally, it is classified as it is a cat or dog. Okay, right. So our deep learning contains artificial neural network and which has multiple layers, as we discussed. So first layer, it will detect the 4 legs and the tail. Second, it is a fluffy. Finally, it will identify all the features. Then it identifies it is a cat. This is how our neuron or our brain is working. The same way the neural network is working. That's why we mimic the concept of our neuron, right? And one more different is our traditional machine learning algorithm. So we have to handcraft the features. What do you mean by that? So suppose if you had the cat picture, you have to you have to handcraft the feature. You have to do the feature engineering. Then you have to collect the feature and give into the algorithm, whether it is a SVM or a decision tree algorithm, right? So then it will identify whether it is a cat or not cat. right? So this is the problem in traditional machine learning. Whereas in deep learning, the features are automatically collected. So it will be collected by our neural network. This is the neural network, right? So it will collect the features. We need not handcraft the feature to them. What is the main advantage of this concept, right? So suppose if you handcraft the feature, then there may be a chance you miss some of the feature, some important features, isn't it? But it lands every feature. Suppose the cat is somewhere else in the image, somewhere else, right? It immediately identifies. That's a wonderful concept of deep learning. This is another different. So that is called a representation learning. Okay. So DL applies, that is a deep learning applies a multi-layer process for learning and hierarchical structures, right? Say for example, so this suppose if I am giving an image like this one first low level features has been identified, and then the mid level like texture that will be identified. Finally, this high level features, I don't know, this is a fan or something like that, it will identify. So this is the working principles of our deep learning. Okay, now I consolidated. So what are the difference between machine learning and the deep learning? So in the learning method, so we have to handcrafted the feature or feature extraction we have to do in machine learning, right? And in deep learning, feature extraction from raw data, it will done automatically. So this is called representation learning. Then algorithm structure, simpler algorithm with limited layers. It can solve simpler problems only, machine learning. Whereas deep learning solve complex algorithm. Complex problem has been solved with multiple layers, right? And data requirement, similar data set may be sufficient, but deep learning requires larger data sets are often required. And application, machine learning, wide range of application, and it is primarily focused on complex problem. Okay, these are the difference between machine learning and a deep learning. So up to this, are you clear? Any doubt? Okay, no doubt. Are you clear? Okay, good, good. So, okay, so now you understand why do you go for deep learning, right? So there are a lot of problems in machine learning. Okay, so a complex real-time problem could not able to solve by the machine learning algorithm. That's why we go for machine learning. Sorry, deep learning. Good. So now, what are the different types of neural networks are there? Okay, so let us explore about, right? So the already we have seen that the perceptron. So this is the simple neural network, perceptron, and next one is feed-forward neural network. We will discuss about that. Convolutional neural network, recurrent neural networks, autoencoder, generative adversarial networks. So these are the different types of neural networks. Okay, so up to this, this is called supervised learning, and these two are unsupervised learning. What do you mean by that, supervised learning and unsupervised learning? Any idea?
Yeah, supervised learning, we have fixed labeled input and outputs are already it is decided.
Yes.
So you have to just get the target variable as per that.
Yes.
In unsupervised, the labeled data is not available. You are trying to gather the patterns from the inputs and then group them.
Yeah, exactly. Good. Super. As I've told, supervised learning, any machine learning or deep learning, we pass the features, right? Feature 1, feature 2, feature 3, and finally we have the target variable, right? Result will be there, right? So these are called, what is the name of this feature? Independent. and this is called dependent. So if you have the result, that is a target variable, right? So then it is supervised learning. If you have only features, F1, F2, F3, I'm having the features alone, right? Then what will do? The machine learning will automatically cluster the data, group the data. Okay, so this is called unsupervised learning. Exactly, very good. Right, so these are the different types of neural network. Let us see one by one, right? So the first one is a perceptron. So this is the simple type of neural network with only one layer of neuron. So it contains only one neuron it has. Okay, say for example, this is the neuron we are having. Okay, so these are the input features, X1, X2, Xm, and this is weight, and this is bias value. And what we'll do here, summation operation has been happened. And here it is sigmoid function. Sigmoid function has been applied. And finally, we got the result. Either it is 1 or 0, right? It just like our neuron. Why it is our neuron? It is compared to our human neuron. Because our neuron, I will explore lately. Okay, so it works similar to our single neuron only, right? So can you get any idea about this one? So you may heard about this part and this part. But some one machine learning algorithm do this job and one machine learning algorithm do
It's like a threshold, sir, like activation.
Activation is threshold, very good. What about this one? Weight and bias, good. So you may heard about this equation y equal to mx plus c.
Yes, sir.
Any idea?
The normal straight line equation with the intercept.
Yeah, so it's a normal straight line equation, and this is slope, and this is intercept. This is the feature, right? If you are having more than one feature, this is you are having. What we'll do? So here you are doing the summation operation. All right. So that thing is performed here. The input feature multiplied with the weight value, all right, and all are summed. Finally, we got the result. So up to this linear regression operation is carried out, right? When you apply sigmoid function, suppose if you get the linear regression equation like this, right? When this value, this equation passed to the sigmoid function, the line will be made as a curved space. What is the name of that algorithm? So there is a
logistic regression.
Logistic regression, very good. That is logistic regression. So it will be converted into S type, right? So there is a problem in linear regression because there are several problems in linear regression that has been solved in sigmoid function by applying the sigmoid. I'm not dealing with that one, right? So that's a machine learning concept, right? So here, what I'm going to stress is, so it is the combination of linear regression plus sigmoid. That is a logistic regression. So this one part is called our neuron. Finally, we got a result, either 1 or 0. So in linear regression, what will be the result? Why we apply sigmoid? So this is the final question, sorry. Okay. So this is the linear regression. Why do you go for sigmoid? Why do you apply sigmoid equation? Or why do you go for logistic regression?
You make a discrete assumptions like classification, sir. If you use sigmoid, you get either a true or false classification for that. So that will be regression, means you will be actually predicting the relationship between the continuous variables.
Yeah, exactly. Exactly, super, sir. So in linear regression, we got some values, as Sir told, we got some values like 400 or 500 or something like that, right? Or negative values we are having, right? But we need either 0 or for classification, you know that it is only give the categorical data, right? Linear regression, it deals with the continuous values. We got like 500, 400, something like that. But I need 0 or 1, right? for the classification. So that's why I apply the sigmoid equation here. And finally, I got the equation. I got 0 or 1. Or the value between 0 to 1. Probability value between 0 to 1. So this is single perceptron. I hope you understand, right? It is nothing but it's the combination of linear regression plus our logistic regression. Are you clear? Are you clear with that? Type yes. Apart from SAR, all other. If you have any doubt, you can ask. Because it is the core part of our neural network. Okay, good. Good. Super. Thank you. So the next type is somewhat detail we are going on. So here we are having multiple layers of neurons. So here we are having the connection between the neurons, right? Say, for example, it do not look back on themselves. I will explain clearly. Okay, so here as neurons, what we have input input features, and we have output, right? Similarly, we are having input layer and output layer, right? In between, the hidden layer has been constructed, right? So the input features, the input neuron, take this neuron, it will connect with all the neurons in the next level. Similarly, from this, the output is connected to all the neurons to the next level. Similarly, it goes on. Finally, we got the output. So the input layer and output layer fixed one, right? Keep in mind. So the input layer and output layer of fixed one based on our requirement. If you have input feature, say for example, feature 1, feature I just now I explained, right? 5 features. How many neurons we are having? 5 neurons. Suppose I'm going to find whether it is a cat or not, right? So based on that, we are having the output layer also. So the hidden layer depends upon the complexity of the problem. If the complexity is high, then the construction of hidden layer will be increased. At the level of neurons also increased. Okay. So this is called a fully connected network or dense network, because each neuron is connected to the next level. And this is feed forward neural network, which means that we did not get the result back, feedback back. So this is a very low level of neural network. Okay. So this is one type of neural network. This is the thing we are going to implement by using TensorFlow, right? And this is convolution neural network. Before feed forward network, it is only for tabular data, right? It only for tabular data. Suppose, but real time we are not having only tabular data, right? So we are having image data, we will having time series data, large amount of data we are having. So based on that, they are constructing the neural network. So convolution neural network, it is exclusively for image processing. Okay, right? It is only exclusively for image recognition. So designed for image recognition and other tasks that involves the spatial data. Okay, suppose if you give you an image like let us say it's a zebra. So what we'll do? So it contains several filters. The filter is nothing but convolutions. Right? It contains several filters. Each filter contains some patterns, the curve pattern, the diagonal pattern, something like that. So the filter traverses the entire image. Wherever it identify, it generate feature maps, right? And we apply some activation function. That activation function is called a ReLU activation function. We will discuss about that, right? And after the result, we got the feature map. We apply some pooling concept, max pooling and average pooling. There are 2 types of pooling is there, right? Based on our application, if it is smoothing, then we go for average pooling. If you want to some other application, we go for max pooling. This is not on our area. Okay, so each layer contains convolution plus ReLU. So that important features has been passed to next level layer. Here also we are performing convolution plus ReLU. Convolution, don't think about nothing. It is a filter, just a filter, right? So plus activation function. Activation function means a linear to non-linear. It makes linear to non-linear. That's all. Okay. So we applied continuously based on the complexity of the problem. We constructed the convolution network. Finally, we got the features, right? Two-dimensional features we are having. Our neural network, that is just now we have seen, right? So it only identify the one-dimensional data. So that will be converted into flattened layer. It will convert the two-dimensional data to single dimensional, which will pass to the network, this network. So this is a dense network, fully connected network. And finally, it will be, the result will be, so suppose if we have high probability value on G-prop, then it will be determined it is a G-prop. So in this way, convolution neural network is working. It is exclusively for image processing. Still now it is used. It has been used in industries, but in different format, VisionNet, something like that, right? Right. So this is the next type of deep learning. And one more next type is a recurrent neural network. Otherwise, it is called as RNN. So it is exclusively designed for sequential data, that is a time series data. Right. So the same structure, but we are having the loop and also we are having some memory. Right. It is explicitly used for natural language processing. What is natural language processing? Any idea? NLP, you may have heard about that. Any application you can tell. Am I audible?
Yes, memory, sir. Recurrent neural networks have memory, so it is able to lap up what has been done, especially for text processing and all. It is
yes. Sentiment analysis, very good, right? Exactly. Okay, so it in memory. Say for example, suppose I want you told us John went to movie. Okay, he John went to supermarket. He purchased something, right? He purchased something. So here he refers what? It refers John, right? As a human, we can understand, right? But how the machine understand? So for that, it keeps the memory. Okay, so this is a simple application. And also, if you type the word as if you type a mail, so automatically it will predict the next line, right? So the highest level application is LLM model. All these are application of a recurrent neural, but it's a very old concept now, but it is eradicated. Nowadays we are using a transformer only, right? So recurrent neural network, it is exclusively for text data, sequential data. And this is unsupervised learning, so auto encoders. So it is used for unsupervised learning, where the goal is to learn the representation of the input data. Say for example, suppose if I have the original image, right, it will be compressed, this will be encoded. Finally, this level I am having the important features only, right? What are the important features of the image I'm having here? So once I decode, the original image will be extracted. Okay, the ultimate aim is there is no difference between this original image and this decoded image. So this is called autoencoder. So in your WhatsApp, they are using this autoencoder concept only. Right. So if you transmit some images, it will compress and the important feature has been collected, and the receiver, once it received, it will be decoded and they got the original image. So this is autoencoder. So this is unsupervised learning. So this is another type of deep learning. And this is some advanced concept, generative adversarial network, GAN. Okay, it is used to generate the stories, fake images. You may had about, right? A lot of fake images has been developed nowadays, right? So they are using this GAN. How it works? So there is two people are the generator and discriminator, right? Generator is considered as an artist. He generate a fake image. He generate a fake image. And discriminator, it is identify the it is a fake. It is like a police. That's why it is called an adversarial enemy, right? So generate an image, and which will be discriminated by the discriminator. He find the fault. This is not the image, original image, like that. So based on the feedback, it will generate another image. Generate another image, and it is continuously goes on. When discriminator could not be able to find the difference between the fake and original image, generator will be, right? The fake image has been developed. Generator. So this is the latest concept, generative adversarial network, GAN. So it is used to generate stories, fake images, etc. So these are the different types of deep learning network. Okay. And if you see the application, there are a lot of applications that has been used, images and speech recognition, like where the object is, what are the scene behind this, and natural language processing, language translation, as one madam tell, the sentiment analysis also it is used, healthcare, autonomous vehicle, finance, gaming and entertainment, lot of field, manufacturing industry, robotics, cybersecurity, retail, and so on. Right. So how do we implement this deep learning? So there are two ways. So please mute your mic. Who is that? Okay. The deep learning has been implemented, will be implemented by using two concepts. Please, audience, you are mute your mic. I think who is that fellow?
And these two are, I think, used by Google and Facebook, and they're like similar platforms, but one is advocating PyTorch and the other one is advocating TensorFlow.
Yeah. So deep learning has been implemented by using, we can implement TensorFlow as well as our PyTorch, right? So as I told, this will be developed by Google team. And this will be developed by Facebook. Yeah. Okay. So, but if you industry, they are mainly using TensorFlow. If you go for research purpose, they are using PyTorch. Okay. So that's all about my first session. If you have any doubt, you can ask, and we will move to next session. Are you clear?
Yes, sir, it is clear.
Okay, thank you. 1 minute. So we are doing some coding. We are going to do some coding, right? So neural network, how to implement. So as already told that it has three kinds of layer. One is input layer, another one is output layer. This is fixed one, right? In between, the hidden layer will be only constructed by us only, right? Good. So what is the function of neuron? Already we have discussed. It has, yeah. So this is the thing I want to highlight. So a biological and artificial neuron, how it is similar. Say for example, in our neuron, so the input signal passed through dendrites, right? The input signal are passed through the dendrite. These are the dendrites, and here some processing is happened. The input signal has been processed, and it will give some send a signal, fire the signal. So based on the processing, it will either fire or not firing. If it is firing, then it is 1, otherwise it is 0. Right? The output signal is passed to this network, axon, and this will connect it to the next neuron. Okay. In the same way, artificial neuron has been implemented. Here also see, instead of dendrites, we are having the input feature. So nucleus we are having here, we are having the what is called a single neuron. So it process summation and sigmoid function, we got the output, right? So in between, we are having some bias value that is used to control the parameter. Okay, we got the output, right? And we got the result. In the same way, we can implement our biological neuron artificially. But it is not possible because we are having more than 8 crores neurons we are having. All right. So there's a power of human neurons. Okay. So already I have told that. So this is the input feature and this is the weight value. And this we are having some summation function and we got some output. What is the purpose of this weight value? Yeah, to give importance to the particular input feature, right? If the feature is important, then weight will be more. If the feature is not important, then the weight will be very less. Okay, so it will be multiplied and we got the summation value, the bias value will be added. Finally, we got the result and we apply some activation function, we got the result. Okay, good. So let the code, just I fastly of the code. So for that, I take collab. No, this is 1 minute. Okay. Oh, sorry. So this is the basic coding only. Yeah. So here I'm having a single neuron. Okay, single neuron which has a 3 input feature. X1 equal to 2, X2 equal to 4, X3 equal to 7. 3, that value is like this. And the weight value is like this. Weight 1 equal to 0.3, weight 2 0.5, which means that it determines the importance of the input feature. And we has the bias value. Like in linear regression, we have intercept value, isn't it? Base value. This is very similar to here having a bias value. So after some performance, the summation, we got some result, right? So how do you implement? Suppose if you take core Python, how do you implement? So you have to create a input vectors, isn't it? So 2, 4, 7 and weight vectors. So this is a list you may studied in Python, right? Weights we are having 0.3, 0.5 minus 2, something like that. And bias initially we are having 2, right? So when you run, we got the output. So the output value will be 3.2. Right? Suppose if you have more input feature, 4 input features we are having, and each has some weight value, the same operation has been performed. Right? Suppose I'm having 10 input feature, what will do? Right? We can solve using NumPy. Right? And also we can do it since TensorFlow. We will see the TensorFlow. Suppose if you have the input layer like this, how do you implement? So core Python is not suitable for that. Right? So that's why we move to TensorFlow. And also there is a problem in core Python, that is a NumPy. Okay, so the NumPy cannot be processed by GPU. Tensor has been processed by GPU. That's why there is another reason we go for a TensorFlow. Okay. Yeah, I will explain clearly with that, right? So let us consider this is the thing we are going to implement, right? Okay. So now we move to TensorFlow. So what is, so now you see the problem, right? How the core Python deals with constructing neural network, right? So it is very difficult to construct the entire network, but we can easily, not easily, somewhat advanced we can do by using TensorFlow. All right. So what is TensorFlow? It is the end-to-end platform for machine learning. So write fast deep learning code in Python, other accessible language, especially it is run on GPU and TPU. Right. Whereas NumPy or core Python only runs on CPU. Right. It is able to run and may pre-built deep learning models, pre-process the data, model data, and deploy the model based on our application. If you go this website, you can learn TensorFlow. So they give more concept about TensorFlow. Okay, right. So what is a tensor? What is a tensor? Say for example,
Computational unit.
Yeah, it is a computation. Let us say about right. What is the role of tensor in neural network? Okay, so I will explain. So here, I think the image has visible to you. Yeah. Right. Say for example, suppose let us consider this is an image. So let us consider, so this is an image deals with the food item, ramen and spaghetti, or another image, another data, I can text data I'm having, right? So I have to find whether it's a mail is spam or not, or I'm having some audio data, right? So here I have to classify the image. Here I have to find the classify the what is called mail, whether it is a spam or not. And here I'm having audio data. What happens? So my neural network model could not be able to identify whether it is an image or mail or audio, right? So that will be converted into numerical data, right? That will be converted to the numerical data, and the numerical data will be given to the deep learning network, and it will also produce a numerical data, right? Finally, it will identify, it will translate it as a human understandable, whether it is a ramen or spaghetti, or it is mail is spam or not spam, or the audio imagination translator like, hi Siri, what's the weather today? I hope this is the flow of our how the neural network is working. Okay, so the whatever it may be, whether it is a video image or a digital image or text data or audio file, that will be converted into numerical data. Okay, and it will pass it to the our neural network. Then we got some output, right? So finally, we got a human understandable format. So this is the core idea where the tensor has been used. So the tensor used here. So these numerical data has been represented by tensors. Okay. This numerical data has been represented by tensor. Since the tensors are flows in the neural network, it is called TensorFlow. That's all. Okay. Are you clear? What is the role of tensor? So it flows in the network. That's why it is called as TensorFlow. Got it? Shall I move further? Okay. Yes. Okay. So it is very similar to NumPy, right? So if you have studied NumPy, then you are familiar with the tensor. That will same concept, right? Suppose if I running this code, it will give the version of the TensorFlow. Right, it is very similar to NumPy. I will explain. So we have studied in mathematics a scalar, vector, and matrix. So scalar is, what is scalar? There is 0 dimension, right? There is no dimension, then it is called a scalar. If it is 1 dimension, right, then it is a vector. Whether it is a horizontal or vertical, it is called a vector. If you have 2 dimension, then it is a matrix. Similarly, we can represent n dimension in NumPy. In very similar way, we can represent tensor also. Tensor also used to represent 0 to n dimension, right? Suppose I want to create a constant, you know the different, what is constant, right? If you cannot change the value, then we can use the constant, right? Tf dot constant, it will create the constant. So I'm not going to deal with deeply because these things all happened internally. We need not to write like this. So the constant used sort of for learning rate. You may heard about in machine learning, you have studied learning rate, right? What is learning rate? We have to use some fixed value, very minimal value. So that's a wonderful concept, right? If you are interested, you can study gradient descent algorithm, right? In that we are using this what is called learning rate, everything, right? So that is a fixed value. Okay, so we never change the value, so that is constant. So for that we use the TensorFlow constant, and a TensorFlow variable also we can use, and we can check the dimension, number of dimensions. Say for example, here I'm creating 2-dimension data. How do you create? Tf dot constant, I'm passing 2-dimension data, right? So it will create a 2-dimension data. And ndim, it is the attribute of TensorFlow. It will give the number of dimension. Similarly, I can create a 3-dimension. What is the 3-dimension? It is 3-dimension is a collection of 2-dimension. 2-dimension is collection of 1-dimension. So that's thing we have studied in our school days only, right? Similarly, we can create a variable also. 1 minute. Yeah. So variable, it value has been changed, right? So any idea where the variable has been used in deep learning or machine learning? Constant has been used already, told that, right? So the learning rate never change. What the data has been changed continuously in neural network or machine learning? Any idea? So the weight value continuously updated, right? So for representing the weight value, we can use the variable. Okay, good. And random sensor, right? So in order to generate the random images, all right. So if you give the continuous image, fixed images, then a neural network easily identify, okay, this one is, if the first image contains, then it is a dog. Second image, then it is a cat, something like that. So you have to random and shuffle the images. So for that also they are having some methods, random, they can create a random tensor. We can shuffle the order, right? So all these things happen internally. So there are all the methods are there. A random dot to shuffle, it will shuffle, right? And we can get the attribute. So just I want to highlight how the tensor is our basic concept of tensor. So this is not our ultimate aim. And we can perform matrix multiplication also. Just like in core Python, you can do, right? So core Python, what we do? So by using this act operator, we can multiply. Same thing we can do, or we can do the dot product, mat. So this is very important concept in machine learning, right? Matrix multiplication. Yeah. And we can find the minimum, maximum, mean, sum, aggregation values we can find, right? Right. So here we are performing simple neuron, here constructing simple neuron. So I construct the input feature as well as weight vector and bias value. So I apply the sigmoid function. So I perform manually. Okay. All right. Good. So this is core idea about TensorFlow, right? Very much similar to NumPy, but it especially used in GPU, right? So that's the main purpose of TensorFlow. That's why we moved to TensorFlow. The flow tensor has been flowed in the neural network. That's why it is called TensorFlow. Okay, right. So the next topic, oh, sorry, I was sort of, there are some more concepts are there. Sorry. Right. So why do you go for neural networks? So there are problems in single neuron, right? In single neurons, so already told that it is a linear regression equation, right? So it solves only linearly separable problem, which means that here I'm having some data, right? So here I'm some class 1 I'm having, here I'm doing class 2. So this is easily separable by the linear regression. Okay, we perform some operation dot product, we got the result, and we apply the sigmoid function. We got, if it is 0, then it belongs to this class, and if it is 1, then it is belong to this class. We can identify easily. Linearly separable problem can be solved easily by single neuron. But in real time, the problem is never it should be linear, right? So it should be non-linear only. How do you solve this kind of problem? We cannot solve this. We cannot solve single neuron. Right? For that purpose only, we go for neural network. So it is easier to solve non-linear problems. Right. Okay. So somewhat advanced concept we are going to see. Neural network intuition. Okay. Let us consider, suppose this is the input image. So I have to classify whether it is a line or not. So this will given to 4 people, right? So this task will be assigned to you. You assign 4 people to identify whether it is a line. You have to instruct them to whether it is identify whether it is a line or not, right? So these 4 people identify the feature and will report to the next people. Okay, let us consider this scenario. What will they perform? So this person will look out to the face. The first person will look out the face of the line. And the second person will look out the body. Third, look out the legs. And fourth one, look out the tail. Okay. By identify the feature, he has to tell whether it is a line or not. Combinedly, the features has been collected to this one, this fellow, and he has to report it whether it is a line or not. After some time, this person told that I could not be able to perform. Right? Why? Because here I have several features, because the face is important to identify, isn't it? So I have to look out several features, but all others are simple one. So I could not able to process. What we'll do? So this fellow additionally give another 3 people to him. Now this entire phase will be looked out these 4 people, and for all others, this one is looked by these people, and this feature are looked by these people, and so on. Okay, so what is the concept behind this? If the problem is complex, we can increase the level of neurons. Consider these the people as the neuron, right? If the problem is complex, then we can increase the level of the neuron. That's the core idea. Okay, so this face picture will looked by the 4 people. So that is eye is looked by this one, and mouth is looked by this one, ear is looked by, fur is looked by this one. Finally, he report one. After some time, right? So these 7 people give the report to this fellow. After some time, what will do? This person, I could not able to do that because this is I could not able to handle these 7 people. So I need assistance. So one more person has been assigned to them. So these 4 people report to him, and these 3 people report to him. So what is the analogy? So if the problem is more complex, we can increase the hidden level layer. We can increase the hidden level layer, right? So finally, they will report to this fellow, and he report to the supervisor, right? It's a line or not. Suppose this fellow, it is a report as it is not a line. It is not a line. So this supervisor give the feedback. Give the feedback to him. So look out these features correctly, right? So what we'll do? This fellow give the report to this fellow, and this fellow give the report to these fellows, and this look out to the pictures more clearly, right? And give the report once again. This process is continuously happen. Keep in mind, these 2 fellow never see the images directly. Only they see the features from them only, right? This is called feedback, right? So this process is continuously happen. So this is called a learning. This process is called learning. I hope you understand, right? Instead of a human, we replace the neural network. That's all. Are you clear? Any doubt up to this?
No, sir.
Thank you. Right. So this is called a training. The training has happened. Okay, good. So now the people has been replaced by our neural network. That is a neuron. So consider here we are having 7 neurons. We are having each neuron look out the features and report to the next level neuron, right? And we got some values. Finally, it will determine line or not. For example, but in reality, what we'll do? So this input neuron is connected to all the next level neuron. Okay, good. And this lines indicates the weight value. If the line is dark, then the weight is very important because the eyes are so important, right? That's why the line is so dark. If the line is very simple, light, then the feature is not important. So it determines the weight value. What has happened? Say, for example, in reality, what will happen? So this the image. So it will be converted into 16 into 8 pixels. For example, let us consider, right? So that pixels converted into a single dimension, flattened by the single dimension. We got single vector, 16 cross 8. This is because in real time we are having 2-dimensional data, right? Okay, we will get single dimension finally. Sorry. single dimension. That input features will given to the hidden layer, and the hidden layer is 128 and 64. Finally, we got the output layer. Here, what is fixed one? What is fixed? So the input is fixed because we are having the 128 values, right? 16 into 8, we are having 128. So for each pixel, we have a neuron. So this is fixed. Similarly, output is 1. So I have to find whether it is a lion or not. That also fixed. So in between, the hidden layer is, it's up to you. You have to construct the input in between layer, that is hidden layer. Whether it is 128 or 256, it's up to you. Based on the complex of the problem, you can increase the hidden level layer. Okay, good. Okay, then what is the role of activation function? What is the role of activation function? Why we need activation function? And what are the properties of activation function? And what are popular activation function we are having? That's the thing we are going to see. Yeah, help a neuron to make decision. Yes, exactly. Good. So the definition is, it is small mathematical formula applied to each neuron's result. So you know that, so neuron produce some result. It may be some value, right? So it performs a mathematical operation, and its job is to add non-linearity. If you are not using activation function, then you will get linear output only. It will not be never non-linear. But in real time, we are having non-linear operation only. So without it, even a deep neural network would act like a plain linear regression. So very important concept, activation function. So the activation function decide whether a neuron fires or not based on the weighted sum of inputs plus bias value. Okay, this helps the network make smarter and more complex decisions. Okay, so at compressing, so this is used to restricting the output to a specific range. This is the first application. That's why we go for activation function, because we are having high value, 500 or 600 something thousand. So I need some specific range. For that purpose, I go for activation function. Okay. Another one purpose is non-linearity, because the output is, if you are not introducing activation function, then any level you can construct, we got to the linear regression output only. So in order you get non-linearity, we apply activation function. I hope you're clear, right? Say for example, what is the role of activation function? I take the same example. All right. So this the input features we are giving line, and these are the 7 neurons we are having. All right. So the first neuron has value like this 1, 1, 0, 0, 1, 0, 0, something like that. These are the input values, right? And these are weight values. These are weight values, right? What will happen? The summation operation has been happened. What is the summation operation perform? This will be multiplied by this value, plus this will be multiplied this value, plus this one. Finally, we got the result, right? Say for example, 1 into 2 plus 1 into 2 plus 0 into 1, 0, 0 into 1, 0, we got 4. Similarly, we got, we are having bias value algorithm, ignore just for a moment, right? Okay, so here also we are having 1 into 2, 0 into 1, 0, 0 into 1, 0. So we got 2. What is the result we are having? Here we are having 4, and here we are having 2. Okay. And here also we are having the weight value. 4 into 2, it is my 8. 2 into 1 plus 2, we got 10 as the result here. So the output is 10. So this is linear. So whatever neural network you have introduced, how many level of hidden layers you can introduce, finally you got what's the value? You got some value, 10 or 100 or 200 something. But what I need whether it is a line or not, right? I need 1 or 0, not 10 or 100 or 1000, something like that. So I have to decide based on the value, right? So here only the activation function plays a vital role. How? Say for example, it applies some function f of x, right? The function will return a value either 1 or 0. How it perform? If x greater than some threshold value, here I just give 0. You can give some more values. Say for example, if you give some 10, right? If x is greater than or 10, then we got 1. If x is less than or 0, then we got 0. If we got negative value, then we got 0. So whatever the value you got, whether it is 100 or 200 or minus 10, you got the result like 1 or 0. So that's the role of activation function. So the range is restricted, and also finally you got a nonlinearity. That's the purpose of activation function. Any doubt? Am I boring?
No, sir.
Yeah. Okay. Okay. Good. Okay. Thank you. 1 minute. I'll take some water. 1 minute. Sorry about that. Yeah. Okay. Okay. So this is the role of activation function. Okay. Okay. So now you understand what is the property, why do you go for activation function, right? So what are the properties of activation function? What are the properties? How do you choose the best activation function? Right? So while choosing the activation function, you have to consider this property. It should be non-linearity. And it is differentiable. I think someone on the mic, right? So please mute your mic. Thank you. Thank you very much. Right. So to introduce a non-linearity, yeah, is there a problem in my presentation or you? Please mute your mic, participants. It is echo.
Everyone was muted, sir, but don't know from where the sound has come.
Okay.
Everyone is muted, sir.
Okay, madam. Okay, okay.
But I don't know from where the sound has come.
Okay, madam. Okay, okay.
Yes, sir.
Okay, continue.
Yes, sir.
So based on the properties, you have to choose the activation function, right? It should produce, it should be non-linearity, right? So the result should be non-linear, and it should be differentiable. Because in gradient descent problem, we apply differentiable, right? We apply the differential, then only the weight has been adjusted, right? So that's the activation function should be differentiable, and there should be a fixed range, all right? Either 0 to 1 or something. It not should be 0 to infinity or something like that. It should be within a range. And another important property is it is monotonic. What do you mean by monotonic? If it is increasing, then it should be increased. If it is a decrease, it should increase. Not in both way, it increase, decrease. That is not allowed. Then it is not a good activation function. Okay, all the properties are made, but it is a very computationally, it is very difficult to compute because we are having a lot of activation function, right? Each neuron has one activation function. Suppose if I apply ReLU activation function, this will applicable all all neurons. Just imagine that how many neurons we are having, right? So it should be computationally efficient. So these are the properties of activation function. So based on that, the activation function has been determined whether it is a good or not, right? So the very old activation function is step activation function. It is very similar to our neurons firing in human brain, right? Suppose if you touch a burning, what is called candle, immediately you took the right hand. How it is immediately took? The signal has been passed to our brain. The brain instruct to the right hand immediately, not the left hand. Right. So the based on the same concept here, the step activation function is working. So it is very old concept. Okay, so just now we have seen, right? We have some threshold value. If the value is 0, then the value is less than 0, we got 0. Greater than 0, we got 1. Correct? Just now we see the example. So this is the function of step activation function. So the properties of this step activation function is it is non-continuous, right? It is bounded. It is not zero-centered. Zero-centered means, so we got the result as 0 as well as a positive value and minus negative value. So here what is the output? We are having 0 and 1, right? So that is, it is not zero-centered. And performance very poor. And use cases, it has been used in hidden layer as well as output layer. Right? Some activation function could not able to use output layer. Because in output layer, what I need either 0 or 1. Some output activation function could not able to produce the result. So that's why cannot used in output layer, only used in hidden layer. Okay, good. Next activation function, it's a very familiar activation function, sigmoid activation function, right? So it uses this function, 1 by divided by 1 plus e power minus x. So whatever the value you passes, whether it is a positive value or a negative value, you got the result as 0 to 1. Isn't it? This is Euler number, you know that, right? Euler number. And this x represent, any idea? The x is nothing but line equation, right? Line equation, y equal to mx plus c equals in, right? That equation. So whatever the value, it will convert it into 0 to 1. If it is positive value, then we got nearly to 1. If it is negative value, then we got near to 0. You know the concept, 1 divided by some more than one value, we got to the some value, right? So this is the result will be 0 to 1. So this is the output of sigmoid activation function. We already studied in machine learning, right? So the properties are continuous and it is also non-linear and it is monotonic. It's bounded, the range is bounded 0 to 1 only. And it is also not zero centered. So we got 0 or 1, 0 to 1, not it is zero centered. And the performance average. Compared to step function, it works very well. And the use case, it is used in hidden layer as well as output layer. So this is sigmoid activation function. So next activation function is a tanh activation function. So this is the formula we are getting. So this is continuous, non-linear, monotonic, bounded, all are similar to sigmoid, and it is zero center. Zero center mean we get a negative as well as positive value. Performance better than sigmoid, and it is used in hidden layer. Why it is used in hidden layer? It is not used in output layer. Why? Any idea? Why it is not used in output layer? Yeah. Okay. Thank you. So why it is, my question is, why it is not used in output layer? Because it result, I need 0 or 1, right? But it will produce -1 to +1. Negative value also it produce because it is a 0 center, right? So that's why it is not used in output layer. And tan H sigmoid faced the vanishing gradient descent problem. You may studied in machine learning, right? Right. So this is vanishing gradient. So if I go deeper, then it will take much more time. So that's my, so it is affected by vanishing gradient descent problem. But that's why we go for another wonderful activation function called ReLU activation function. So this is mostly used. ReLU activation function. So it is solve vanishing gradient problem, right? Say for example, the function is very simple, max of 0, x. Max of 0, x.
Hello, sir.
Yes.
Sir, sorry for the interruption, sir.
Yes.
One question, sir. Can
Yes.
it be applied to quantum cryptography?
Can we apply to
Quantum cryptography or quantum data matter?
any application you can implement?
Okay, sir.
Any application you can implement deep learning machine learning, either it is a cryptography, quantum cryptography, right? So you can apply the deep learning concept.
Thank you.
Yeah.
Okay.
Okay. Thank you. Okay. So good. So what is the function max of 0, x? So it will produce 0 or the maximum value. Okay, say for example, the output is the final output. I got 100. What is the output of this function? All right. Finally, I got output as 100. Suppose if I ReLU activation function, what is the output? Very simple. This apply the simple concept, right? Max of 0, 100. What is the maximum value here? Yeah, 100. Yeah. Yes, exactly. 100, right? So we got 100. So maximum value is 0, 100. Compare this, right? So we got 100, right? Suppose if I'm having negative value, max of 0, minus 100, what will the output? Zero. Yes. Right. So this is the working principles of activation function. If it is negative value, you get 0. If it is positive value, that positive value passes to the next layer. Right. So that's why it is used only in hidden layer, not it has been used in output layer, because output layer, what will need 0 or 1, but it will produce 0 to maximum value. Okay. So, and it is better than sigmoid tan H. Right. Okay. What will do? Right. So next we are going to see, we are going to implement the concept by using Keras. Before that, we are going to study what is Keras, everything, right? Okay. Right. So anatomy of neural network, how a neural network has been worked. So it contains the layer which are combined into a network, right? So the input data and the corresponding target we have to find. So the input data is given and finally we got the output, right? In between, we apply some loss function. It very similar to machine learning, right? Where we have to apply loss function, which defines the feedback signal used for learning. And one optimizer we need, which determines the how the learning is proceed. So based on this anatomy of neural network, Keras has been constructed. Because if you using TensorFlow, it is very difficult. By using Keras, we can easily simulate ANN or CNN, RNN, anything we can do, right? How do you perform? So suppose if you pass the input value, input X, so it gives to the layer, right? And we got the some result. This is Y hat. What it means? It is the predicted value. And Y is, it is the target value, true target, actual value. So the difference is determined by the loss function. Okay? The difference is error. You may studied in machine learning, right? Y minus Y hat. So it produces the error. So what is our ultimate aim? So we have to reduce the error, isn't it? We have to reduce the error. So what we'll do, this loss function, it could produce some loss score that will be adjusted, given by the optimizer. The optimizer adjusts the weight, and once again, it will, the learning has happened, right? Once again, the prediction. So the actual value, find the error value until the error should be minimized if the process has been continuously executed. I hope you understand how the neural network is working, right? So we have to reduce the, this is called gradient descent problem. We have high error, right? So you may see the pictures in several examples. So initially we have high error here. So this is called a global minima. So from this, we have to step down this error. For that only this loss function and optimizer has been used by adjusting the weight. Until you have to reach the global minima, it has been processed. Okay, so how the neural network is constructed? Before that, we must see the introduction to Keras. So Keras has been developed by this fellow. It's a deep learning framework for Python. And it is used to build and train deep learning models easily. And it is simple and user-friendly. And it has been developed by Francois Collot. So he is working in Google, designed for researchers and AI developers. Initially, it has been designed for researcher and AI developer. And it supports deep learning models like CNN, RNN, GAN network. And it works with the TensorFlow, right? TensorFlow we can work. This is the product by Google. Theano we can work. And CNTK, it is the product of Microsoft. That also it can support. So they are used as the backend. By default, TensorFlow is the backend. Okay, by default, TensorFlow is the backend. So it is the open source and widely used. Anyone can use. Both runs in CPU and GPU. Right? If the application is complex, you can choose GPU. So this is the architecture of Keras network. So currently the 3 existing backend, TensorFlow backend, this is the default one, Theano backend. Apart from that, we have Microsoft Cognitive Toolkit, CNTK. So Keras, TensorFlow, Theano, this layer is a TensorFlow or Theano or CNTK. And this is used for mathematical purpose, right? Matrix addition, multiplication, we can do this here. Underlying, we can use either GPU or CPU. So this is the hardware architecture of our Keras. Okay, how the Keras is working? Very similar to machine learning model, right? So first, what you have to import libraries, right? So what we'll do in machine learning, we have to load the data and pre-process the data, define the model's architecture. This is very important. This has been done by Keras. Once we define the architecture, then we have to compile the model. Then training has happened, right? After training, evaluation has been performed. Finally, we predict. It is very similar to machine learning, right? Machine learning also, we are doing the same thing. Good. So that there are 2 ways of building model in TensorFlow. One is Keras sequential APL. At name itself, it tells, right? Sequential means sequentially constructed layer. So it is used to construct the layer sequentially. And this is functional API. It is more advanced version of sequential API. So we are not looking at this one functional API. We are only deals with sequential API. Apart from that, there are model subclassing is there, right? Based on your application complexity, we can use. Okay, good. The Keras sequential API is the simplest way. Even a school boy can easily construct the neural network by using this Keras sequential API. Right? So it is used to create a deep learning models in TensorFlow. It allows you to build a neural network layer by layer, where the data flows in one direction from the input to output. So why use Keras sequential API? It is easy to understand. It follows simple linear structure. It quick implementation, ideal for beginner. Suppose if you are very beginner, then you can choose Keras API, sequential API, and you can solve the problem. And works well for most problems. It is suitable for image classification, regression, simple NLP tasks we can use. Right. So just now we have seen, suppose I'm going to implement this network. Right? It is a neural network. It has three input feature, 4 neurons in the hidden layer, and 3 output neurons in the output layer. Right? This input all connected to next level layer. This is a fully connected network or dense network. Okay. Each has one bias value. Each has one bias value. Suppose if I am using TensorFlow, how do you construct? You have to use like this much of code. So you have to give the inputs features. So we are having 3 input features, right? So shape equal to 3 input features, single dimension, scalar only. So I create 3 input feature, and I have to give the weight value. So 3 cross 4. Why 3 cross 4? So here we are again 3, 4 hidden layer. 3 cross 4. I have to give the weight value. Bias value is 1, 4 bias value. Each hidden layer contains 4 bias value, right? So I have to define like this. And the output is first it is multiplied and it's given to the next layer, right? This is performed here. And here also we are having weight value that will be multiplied. This output is multiplied this weight value. Finally, it is passed to the next level layer. So here we are doing, finally we got the output. See how it is difficult. Suppose if the neural network goes long, it is very difficult to implement TensorFlow, core TensorFlow. For this kind of network, I have to write this much of code. Okay, right. So in Keras sequential API, we can construct easily. So there are 3 components in sequential model, right? One is input layer, which takes the input feature, for example, image pixels, numerical data. And hidden layer, we have to process the data using neurons, right? So here we are using dense network, right? If it is a tabular data, we can use dense data. Suppose if you go for image processing, then you can use a convolutional neural network, convolution 2D. Just you call this function, that's all. If it is RNN, you can use this function, LSTM. Based on the application, we have to choose the type of network, hidden network, dense, convolution network, or LSTM. So today we are going to see about how to construct dense network. Dense network, what do you mean by dense network? It is a fully connected network, right? Each neuron is connected to the next level neuron, okay? Output layer, we provide the final prediction. So we have input layer, hidden layer, and output layer. How do you construct? So dense layer. So each layer in Keras has a specific function. Dense is a fully connected already. I told that this is the general format. So dense, how many neurons you wanted? Just you have to specify units equal to how many neurons. And what is the activation function you are going to use? Right? The unit specify the number of neurons. Activation define how neurons activate. And activation function we have studied, right? ReLU, sigmoid, softmax, linear is there. We will see, right? See, very simply we can construct. Just called sequential. It's a function, sequential, and it's the list, right? Within that, I have to tell how many neurons you are going to construct. So I'm going to construct dense network that is fully connected network. 4 Why 4? Why 4? Because I'm having 4 neurons here, right? So here in this hidden layer, I'm having 4. That's why I'm giving 4. All right, 4. And activation is ReLU. I'm going to apply ReLU activation function. So I have to tell the input. Initially, it does not know about input. So I have to specify the input space is 3. Because why is it 3? Because I'm having 3 input feature. So initially, I have to specify the input feature. That's all. See how simple is this 2 layer of constructor. So I have to specify 3 and 4 neurons in the hidden layer. And 1 output layer, which is also dense layer. So dense of 3. Activation is linear. Right? Activation is linear because I need 0 or 1, right? So based on that application, you have to specify whether it is a linear or sigmoid, you can apply. So the neural network is ready. That's all. Instead of writing so much code like this, I'm writing 3-line code. So how to add layers dynamically? This is more simple, right? Simpler version of sequential. Suppose I want to add it dynamically. So you use this function. Just a model equal to sequential. You call this function. Just model dot add dense of 8. What it means that it has 8 neurons in the first hidden layer. And activation is ReLU. Input is 2 input feature I am passing. This is the first hidden layer. Second hidden layer I'm passing 4. I'm creating 4. Activation ReLU. This is the second hidden layer. And this is output layer. I'm having only 1 neuron. Sigmoid, because sigmoid written either 0 or 1. So the 1 is more than enough for me. So in this way, I can add the layers dynamically. So in this way, you can define the architecture of a neural network. I hope you understand, right? Any doubt up to this? Are you clear? Shall I proceed further? Okay. Only 1% answer. What about others? Yes. Okay. Thank you. Thank you. Thank you. Because in online teaching, this is the biggest problem, right? I could not able to identify whether you are listening or not. Okay, good. Nice. Thank you. Okay. So once my architecture is ready, I have to compile the architecture, right? So here I have to specify this optimizer and loss function, right? And just now we have seen the role of activation and loss function and what is called, sorry, this one, right? So I have to specify this loss function. There are a lot of loss function you may study, right? In machine learning, MSE, MAE, or a lot of functions are there. Based on your application, you have to choose the loss function as well as the optimizer. Okay, and then my architecture. I have constructed the architecture, isn't it? 1 minute. Yeah. So model.compile. So already my model is ready. I defined the architecture. And I have to compile. So by using the optimizer. So here RDM optimizer is the best to use one. And the loss function is MSE. This is used in linear regression and logistic regression, right? So we have to decide which optimizer you are going to use. So there are a lot of optimizers there. What is the role of optimizer? It adjusts the weight. It adjusts the weight based on the loss function output. Okay. And you may heard about the optimizer, right? SGD, stochastic gradient descent optimizer. So it is for randomly used. ADAM, it's the best one, adaptive moment estimation. If the data set is large, then we can use. Similarly, RM's prop based on the application, RNN application, you go use this optimization. If the data is sparse data, like movie representation, Netflix, right? You go for ADA-God. So general deep learning, you can add all that. So based on your application, you can choose the optimization. So mostly use ADAM optimization only. So what is the loss function? The loss function measures how wrong the model is. It is used to compute the error value. Okay, good. So MSCE, you may had about a mean square error. We have to sum all the error and we find the mean value, right? MAE, mean absolute error, binary cross entropy, binary classification for that use. Categorical cross entropy, suppose if it is a multi-class, then you can use categorical cross entropy. Based on that, you can use the loss function, right? Okay. So this is the simple example. Now I compile entire thing, all right, from TensorFlow Keras models, right? So in this package, so we have to import sequential packets, sequential API. Then I have to construct the dense network, right? If it is convolutional neural network, you have to use convert 2D. Here I'm going to construct the dense network, fully connected network. That's why I'm importing this one. Then create a simple model. Either you are, so here I'm using only simple model, which is contains 10 neurons in the hidden layer and activation function relu. Input CP is one, only input is I'm passing and one output layer. Very simple one. Okay. And by using compiler, as I compile this model, one I suppose if you print, you got the result. You can get the result of your summarization of your model. I will show everything. Okay, once my model is ready, so I have to train the model by using the training data. So as usual in machine learning also the fit method is used, right? So it is used to train the model. Okay, training has happened. What do you mean by training? So it given the model data, so it correct. So I will show everything, right? So model.fit, we have to pass the training data, X train and Y train. What is X? What is Y? Any idea? What is X or what is Y train? X train, Y train. This is very similar to machine learning. Machine learning also, we are doing the same process. Yeah, input output, exactly, right? So X is input features, Y is a target variable, right? Epochs equal to 10 means 10 times it entirely read this data. Right? If your data contains 1,000 records, 10 times it reads the 1,000 records and it lands. And batch size we can specify. For each time it will read 32 records. If you are omitting, by default the value will be 32. Okay, so what each part means, X train, Y train, it is the training data. Like Madam told, it is a feature, input feature and labels. X is input feature and Y is a target variable, right? Epochs equal to 10 means the model sees the entire data 10 times. Batch size 32 means the model process 32 samples at a time. I hope you understand, right? Finally, we have to predict, right? So here prediction has happened. So here I'm passing the testing value. That is unseen data has been given to the model and it will make the prediction. Very similar to our what is called a machine learning model. The machine learning also, we are doing the same process. But here we are doing one thing extra. That is we construct the model, create the architecture of the model. Okay, so there are some drawbacks out there. So the multiple inputs, it cannot be processed. But in real time, we have multiple inputs only. We can process image data, we can process sound wave, right? Real time like this. Okay, so we cannot do that in sequential API. That's why we go for functional API. I'm not dealing with that. Okay. So I show the construction of Keras. Then we move to a simple application. Okay. Yeah, after this we got started, right? So this is core Python. and this is TensorFlow, how to construct the network. So this is very difficult, right? So we have to write too much of code. So here I'm defining the multiple layers. So sequence layer I have, by default Google Colab it contains, so you need not to install anything. So Keras, it's supported by Google Colab. And here what we have seen so far, right? So I'm going to construct the sequential model. Right, this is the summary of our model, right? So it contains dense network which contains 16 parameters. Why it is 16 parameter? Why it is 16 parameter? Because we are having 4 input neuron, right? 4 hidden neurons, right? Each process the input and one bias value. 3 plus 1, 4. 4 into 4, 16. So we got the 16 value here, parameter. Similarly, the next level we are having 15. So this is model summary, but this is not our work. So we can construct the what is called sequential API like this, and we can apply our application. I will show this is not our. So I go to real-time application. 1 minute. Yeah. So this is my last session. Don't worry about that. Okay. Here we are going to implement a sequential API, right? So we are going to implement MNIST handwritten digit classification. Okay, good. So what is MNIST? So MNIST is nothing but it contains 70,000 small images of digits. That is handwritten by the high school students. It is taken for compiled for research purpose only. What contains? It contains 70,000 small images, numbers, which will written by the high school students, because I written 2 like this, somebody like 7 like this, I written like this, right? So all these are compiled. They are having 70,000 small images, which is handwritten images, and the employees of the US Census Bureau. So all images are labeled with the respective digit they are represent, which means that it is a supervised learning, right? It contains the label. And it is called Hello World program for deep learning. In any programming, if you are going to study it, that you have to write the Hello World program, right? So this is the Hello World program of deep learning. And 70,000 images, and each images has 28 cross 28 features, pixels we are having. Like say, for example, if I am having 5 as the input number, right? It contains 28 pixels, X value and Y axis, height and width. Because this is the black and white image. So I'm having 2 dimension only. If you are having color images, then you have 3 RGB value, right? So here we are having for grayscale or black and white, we are using 2 dimension only, right? Each image contains 28 cross 28 pixels, right? That is 784 features we are having. 28 into 28, we have 784 features. Each image is 28 cross 28 pixels, and each feature simply represent 1 pixel's intensity from 0 to 255. 0 means block. Say for example, here see, these are all 0, right? So these are represented by 0, which is black. And 255 means intensity to white. For example, this here we are having 5, sorry, dark value, white. So this is nearly 254 or 253, something like that. 0 represent black, no brightness. 258 represent white. And 1 to 255 represent different shades of gray. I hope you understand the image structure, right? So this is the structure of MNIST data. So how many instances we are having? 70,000 images we are having, and a number of attributes 784. We cannot process by using machine learning because it is very high. We can process, but it will be very slow. Okay, the column represents the digit that is a 0 to 9. So this is 0, this is 1, 2, 3, 4, something like that. And the pixels 1 to 7, each pixel value is 2 to 255. So represent the grayscale intensity corresponding to the pixel image. Okay, this is the MNIST test data. Okay, so the data set is divided into two main subset. Okay, one is a training set, another one is test set. In machine learning, we have studied, right? Training and testing. What's the difference training and testing? By using the training data, our model will study, our model will learn. The testing data has not been shown to our model, which means that the 16,000 images has been read by our model and it is lands, right? It land. Training has happened. Okay, so test images, it contains 10,000. You need not to separate training and testing. It by default, they separated. Once you loaded, automatically the images has been separated. 60,000 for go for training and test for 10,000 images for testing. And it is used for evaluating. Okay, so this is the structure of MNIST data. So the task is to classify a given image is 0 to 9. We have to 0 to 9. Okay, so top performing models are deep learning convolutional neural. It produce 99%. Even we are going to use sequential API. This will produce 98%. That's why it is called a Hello World program. Okay. So this is the final output we get. So suppose if you pass the input image 5 to our neural network, we got some probability value. For example, we got 1% of confidence, 1%, something like that. Wherever we got the high confidence value, high probability value, that will be selected, that will be the output. Right? Here I am passing 5. Here I am getting the high probability value 5. Then it will be determined as 5. Okay, good. Now we are going to implement, I think half an hour is there. Okay, good. I can finish. Right, so I have to import a TensorFlow and import a Keras, NumPy for numerical calculation, Matplotlib for visualization. Okay, and so already I told that Keras.datasets. So Keras contain a lot of datasets, right? One of the dataset is MNIST data. Right, you need not to download, just you can load MNIST.load data. Load data in sklearn also they are built-in data, iris data, you may study it, right? So just you can, if you load, automatically it will be loaded. You need to download. So the same concept. Keras contains this MNIST data. Okay, so it automatically separated into training data as well as testing data. You need to perform a train and a test split. So automatically perform. Okay, X train, Y train, images and the labels for train. Y contains the label, X is the input features. What is the output of this one? X train shape and X test shape. What is the output? If I am running this code, what I'm getting? Row, column. Okay, what is the value? See, now we got idea, right? So training set, how much value it contains? 60,000. Test data, it contains 10,000. What I'm printing? I'm printing the shape of the training and the shape of the test. What is the shape? What is the value here? 60K, very good. 60,000, 10,000, right? 60,000 for training, 10,000 for testing. Okay, automatically we get the result. And 28 means it is the pixels. Okay, this is the shape of the matrix. Okay, then I have to normalize the data. So this thing also you have studied in machine learning, right? Why do you normalize? Any idea? Why we normalize? Because we got the value as 0 to 255, isn't it? Based on the pixel value. If the pixel is bright, then nearly you got to 255, 254, something like that. If the pixel is black, then you get nearly zero, near to zero. Why do you normalize? So I need different variants of data, right? 0 to 255. So I have to convert it into 0 to 1. How do you make that? So by dividing 255, I got the result, right? So 0 to 255 will be converted into 0 to 1. It is better for training. That's why we should normalize. Then I have to define the neural network, right? So here I'm specifying Keras sequential by using this method, right? So this is a flattened network because 2-dimensional will be converted into single dimension because our neural network only understand single dimension only. That's why I'm using flatten. You need not to reshape, perform reshape operation like this. In core Python, we perform reshape something like that. If you use this, the flatten method, automatically the 2-dimensional data will be converted into single dimension. That is a 28 into 28. Okay, what is the result? 784. This is the output we are getting. Can you tell how many input neurons we are having? How many neurons we have to give here? Okay, so 28 cross 28, this is the input which we are having. So we got 784. So this is a 2-dimension. We have to convert into single dimension. How many neurons will be in input layer? Yeah, 28 plus 28, that is 784. Right, 784 input neurons we should construct. That's why here I'm saying. So it will automatically converted, right? 28 into 28, 784 we are having. And this is used to construct the hidden layer 128. Why it is a 10? Output layer is a 10 neurons. Why? I hope anyone can answer. It's a very simple concept. Why we are having 10 as the output layer? 10 neurons in the output layer. Yeah, because 10 possible digit, right? So we are having 0 to 9, right? 0 to 9. So the output will be 10. So that's why we are having 10 neurons. For each digit, 1 neurons will be considered. That's why we are getting 0 to 9. Okay, I hope I understand. Then we can compile the model, right? So once I define the architecture, I have to compile the model by specifying the optimizer. Optimizer is Adam. Loss is sparse categorical because it is categorical data, right? Multi-class classification. So I have to use this loss function. On matrix, I can use accuracy. Good. Model.fit is a training has happened. X train, Y train. I pass the input feature and output label. Epoch is 5. What do you mean by that? 5 times it will read the entire data. 60,000 images has been read by 5 times. Okay. Finally, I evaluate the model. I perform what is the result of the model, right? I can predict. So I pass some input images. It should predict whether it is 0 or 9, something like that. And I can visualize the data, right? Okay. So now we are going to implement that concept. So are you clear? Up to this, are you clear? So here we are going to see the next concept, that is that is the 1 minute. It's separately available. 1 minute, I will open that file. One minute. We'll make it. Yes. Okay. Right. So these are the file I have already imported. So right. So TensorFlow, Keras for sequential API, and NumPy for numerical calculation. And this is inline. The output should be within the canvas. So that's why I imported this inline. And I have to construct the pie plot. So I'm going to plot the figure. So I'm using matplotlib. Okay. So just I run this. So first time it will be slow. Next it will quickly process. So what we'll do, keras.dataset mnist load dataset. The dataset has been loaded, right? So it is divided into training data as well as the testing data. Okay, good. Sorry. Then suppose if I running, I'm finding the length of the training data. So it is 60,000 because automatically the training data has been separated. 60,000 images has been separated. And this is 10,000 images has been for testing, right? And this is suppose I want to check one image value. So this is the shape of the image 28 cross 28. Suppose if I'm printing 100, the output is 5, right? So the output is the training data is 5. Similarly, white train of 10, it will give 3. Right here, I'm normalizing data. It is converted 0 to 1. See, the entire data has been converted into 0 to 1. So initially what we'll have, it will 0 to 255 we are having, right? So that will be converted into 0 to 1. 0 means black, and near to 1 means white. So this is the output we are getting. So here I'm constructing the sequential network, all right? So initially I construct the flattened network that is 28 cluster because we are having 784 features, right? So this is up to you. You can give 128 or 256 based on that you can give. So this the output is 10, right? So the 10 now because 10 digits is there, right? Here the model has been compiled by using the optimizer, Adam optimizer, and sparse categorical cross entropy. Here the training has happened, right? So training, I pass the training data and epochs is 5, right? It will read the data 5 times. 60,000 images has been read 5 times. It will take some more time. So what is this? What is called 1875? Why it is 1875? So this is epoch 1, right? We are going to implement 5 times. It will read the data, right? 5 times 60,000 images read by 5 times. So epoch 1 is 1 time it read entire data set, right? For each time we pass 32 images. That is batch size is 32. Okay. So that's why we got to 1875. So 1875 into 32. That's the one time call. Similarly, we got a second time, fourth time. And this is accuracy. Initially, see the accuracy is 87%. Slowly it is increased. 96, 97, 98, and so on. Finally, we got if the loss is reduced, there is no change in loss value, it stops. Okay, so finally we got 98% accurately our model is working. Okay, so now I am passing the X test data. It will make the prediction. All right, so it give the output like this. What it means, it gives the probability value, right? So 9.99, 1.66, 1.91, and something like that. Whichever is the highest value, that is the output. So this one represented 0. This is 1. This is 2. This is 3. This is 4. This is 5, and so on. What is the value we are having? Right? Here we are having the highest value like this. So the 10th prediction is 0. Okay. Say for example, suppose I print, it will show the output. Yeah. See, 0. Say for example, suppose I pass some other number, prediction of 100. Right here also I'm passing the 100. You can check whether it is correctly work or not. Can you tell what is the value it will produce? Which number will be the output? What is the output of this one? Have you understand, right? What is the output of this one? Do you understand my question? If I am passing prediction of 100, what will be the output here? So the first one is 0, second one is 1, third one is 2, and so on. Whatever they got the highest value, that will be the result. So 0, 1, 2, 3, 4, 5, 6. 6 has the highest value, right? 9.999 something. So the output will be definitely, yeah. Sorry, if I show this, we got the 6. Yeah, see. So in this way, it will work. Okay. And I can show some prediction to you, how it correctly predicted. So predicted is 0, actually is 0, because our performance is 98%. Then rarely it will perform very wrong, right? And I can show the value. This is not useful for you. Okay. Yeah, once again it is working, right? Yeah, this is confusion matrix. Okay, I think it is I change the code, something like that, right? So now you understand how the neural network is constructed and how it is used for application. Here I am using MNIST handwritten dataset. Similarly, you can construct the neural network by using the Keras sequential API, or if you want a functional API, and you can implement your own application. Suppose if you are going to identify whether it is a cat or dog, right? You have to train the network by using the images. So based on your research or based on your need, you can implement this kind of network. Okay. So that's all about my session today. I hope you can understand somewhat. If you have any doubt, you can ask.
A broad
Yes.
informative session, sir.
Okay, ma'am. Thank you. Thank you.
A very broad and informative session, sir. Super.
Oh, yeah, thank you.
Participants, if you have any queries, please unmute your audio and you can ask the questions.
Thank you. And thanks for Anshul Rawat. So she continuously give the answer. Thank you for you. Thank you.
Good evening, everyone. It's my honor to deliver the vote of thanks on this fourth day of our AICT ATAL FTP on data-driven model, empowering academicians for the data science era, organized by the Department of Computer Application, Nada Saraswati College of Arts and Science, Theni. I would express my heartfelt gratitude to our esteemed resource person, Dr. R. Lawrence, Managing Director of Macwell Software Solutions, Sivakasi, for sharing his profound knowledge on deep learning with TensorFlow and neural network architectures. His presentation was insightful and inspiring, offering participants a deeper understanding of MNIST, Keras, TensorFlow with more practical knowledge. Thank you very much, sir, for this wonderful session. My
Thank you. Thank
heartfelt
you.
appreciation to all the participants from various institutions for your interaction throughout the session. Once again, thank you all. Thank you very much, sir.
Thank you. If you need any help in artificial intelligence, machine learning, or deep learning, you can approach me, right? So
Okay.
we are doing machine learning and real-time projects also, and we are developing Menstock, and we are providing training also. If you need any help, you can help. So thank you all. Thank you for the
Thank you.
opportunity, madam. Uma, madam.
Thank you very much, sir. Thank you,
Thank
sir.
you.
Thank you.
Yeah.
Thank you, participants.
Yeah. Shall I leave,
And
madam?
yes, sir. Thank you, sir.
Thank you.
Participants, the feedback link is shared in the chat window. You please do fill it. And tomorrow we have the 2 sessions on data visualization.
Very excellent session, sir. Thank you so much.
Thank you, sir.